Ever looked around and thought, what is all this stuff actually made of? From your phone to your shoes to the air you breathe, it's all matter. Matter is anything that takes up space and has mass. So stars, air, water, trees, tables, even your body and your brain, that's all matter. But sound, light, your feelings, not matter, just vibes. All matter is made up of molecules, and molecules are made of even smaller pieces called atoms, which is the basic building blocks of all matter. When two or more atoms bond together chemically, they form a molecule. Think of a molecule as a little team of atoms working together. So, what exactly is an atom? An atom is tiny, about zero point 0.1 nanometers in radius, and made up of mostly empty space. At its center is a dense nucleus made of protons, positively charged, and neutrons, no charge. Orbiting the nucleus is a cloud of electrons, which are negatively charged. Electrons move in specific paths called shells or energy levels. The closer the shell is to the nucleus, the less energy the electrons have. The farther away, the more energy. The number of protons in the nucleus is called the atomic number, and it tells us which element the atom is. For example, an atom with 6 protons is always carbon. The mass number is the total of protons and neutrons combined. In a neutral atom, the number of protons equals the number of electrons. But if an atom gains or loses electrons, it becomes an ion. Lose an electron, it's a positive ion. Gain an electron, it's a negative ion. Each energy level can only hold a certain number of electrons. We can use the formula 2n squared to figure this out. For example, the first shell, n equals 1, holds 2 electrons, the second holds 8, the third holds 18, and so on. How many energy levels an atom can have? Is it a fixed number, or does it change? In an atom's ground state, that's when it's calm and not absorbing any extra energy. There are up to 7 known energy levels where electrons can hang out. These are the levels we see most often, and they match up with the period numbers on the periodic table. For example, an atom in period 3 has electrons and energy levels 1, 2, and 3. As you move farther from the nucleus, each energy level holds electrons with more energy. Electrons don't just slide smoothly between levels. They can only jump if they absorb a specific, exact amount of energy. But here's where it gets interesting. If an electron absorbs energy, it gets excited, literally. That means it can jump to a higher energy level than normal. And technically, there's no limit to how high it can go, as long as there's enough energy. And when that excited electron drops back down, it releases that energy often as light. And that's exactly what's happening in fireworks. When they explode, the heat and energy excite the electrons in atoms. The electrons jump up, and when they drop back down, they release that energy as light. Different atoms have different electron arrangements, so they give off different colors when their electrons fall back. Examples: red from strontium, green from barium, blue from copper. All known elements are organized at the periodic table, created by Dmitri Mendeleev. Elements are arranged by atomic number in rows called periods, and columns called groups. Metals are on the left. Nonmetals are on the right. Group 1 and 2 elements are metals. Group 6, 7, and 0 are nonmetals. Group zero elements, the noble gases, are super stable. They don't like to react. Atoms form molecules to become more stable. Sometimes atoms transfer electrons. This forms an ionic bond. For example, sodium gives up an electron to chlorine, forming table salt NaCl. Other times, atoms share electrons. Well, that's a covalent bond. This happens when two nonmetal atoms come together, like hydrogen and oxygen forming water. Atoms can also share multiple pairs of electrons, creating double or triple bonds. Carbon dioxide is a great example. One carbon atom shares two electron pairs with two oxygen atoms. From the tiniest atom to the vastness of space, everything that's something is made of matter. And matter? It all comes down to atoms and how they bond. Thanks for watching. Like and subscribe for more awesome science content.